Hi guys, welcome to my next video on important functions in the study of calculus. Here I'm going to cover some trigonometric functions. Okay, I decided to do a separate video just on trigonometry because there's a lot of interesting details in here and there's a lot of problems that I see with that you could possibly have using this information. Okay, if you look at YouTube or if you go to Stack Exchange and you look at math problems, there's a lot of questions related to trigonometry. Okay, so I thought I'd go and give a nice detailed breakdown of it. So let's start with the two basic functions of trigonometry, the sine function and the cosine function, okay? So the domain of the sine function is minus infinity to infinity, okay? Minus infinity to infinity. The range is interesting. The range of the sine function varies between -1 to 1. It doesn't get bigger than -1 and it doesn't get smaller. It doesn't get smaller than -1 and it doesn't get bigger than 1. Okay, inclusively. Actually, let me just clean that up right now. So -1 and 1 inclusively. Okay, so the thing about the sine function is it's periodic. So this period just repeats itself over and over again. And the length of a period is 2 pi. Okay, so actually it's this part that's repeating over and over again. And you could see it starts to repeat here. So if I continued on, it would continue on like this. Okay, another thing to note is that the sine function is an odd function. Okay, and we could see that if we look at pi over 2 and minus pi over 2. So f of pi over 2 is equal to minus f of minus pi over 2. And if you remember from my previous video, I'll put the link somewhere up here, that this is the definition of an odd function. So sine is an odd function, okay? So the next function that we're going to look at is the cosine function. The cosine function is also periodic, okay? It's just shifted by pi over 2 actually to the sine function, okay? So the domain of the cosine function is also minus infinity to infinity, okay? And the range of the cosine function is also -1 to 1. Now the interesting thing about the cosine function is that it's an even function. It's an even function. So if we look at the definition of, let's take pi over 2 again, even function. See, we see that pi over 2 and minus pi over 2 are the same value, 0. They're both 0. See? So that's another interesting thing to note. It's also interesting to note that if we shift cosine by pi over 2, we get sine. It's just shifted this way. Okay? So that's it, guys. That's the first part. Now I'm going to move on to the unit circle. Okay, guys, let me continue on with the unit circle. So before I start, I know this is a lot of information. I took the liberty of writing all these details out before we start so I don't bore you as we start the video. So this is the unit circle. We've seen it before. It's usually expressed in the form y squared. Let me get my pen. Y squared plus x squared is equal to 1. Okay? So what is the unit circle useful for? Well, it helps us identify the value of sine and cosine at different angles. Okay, so let me express what I'm doing here. Okay, so if I drew a line from the origin to here, like so, okay, the angle here, this angle here is equal to pi over 6. Okay, and the where this line of with angle pi over 6 intersects the circle, there is going to be an x coordinate and there's going to be a y coordinate. The x coordinate is 3 over 2 and the y coordinate is a half. Okay, now what what else does that mean? So what else that means is if I did sine of this angle at this sine of this angle, it would be the y value. Okay, and if I did cosine of this angle, it would be the x value. Okay, so basically what we use the unit circle for is when we have common angles and we want to know the sine and the when we want to know the sine and the x value for these common angles. Okay, so in general, guys, all you really need to know is pi over 6, pi over 4, pi over 3, and these values. Because what you'll realize is the other values here, they're just reflection, right? This is just going to be, this value here is just a reflection about the y-axis, okay? And this value here is just a reflection about the y-axis. Here, it's a reflection about the x-axis. So if you know these values by heart, you could use symmetry to find the rest of the values. Okay, and why is this useful? Why? Well, when we're solving problems, once we solve enough of them, these numbers are going to be, we'll know them by heart. And the majority of the problems that you're going to solve, they use these common angles, guys. They don't use most problems don't use like some exotic value of pi and expect you to know the x and y coordinates by heart. Okay, so some teachers, they ask you to some problems that some teachers ask is where they give you parts of these values and they expect you to fill out the unit circle by using logic. So what I suggest for you to do is to pause this video, look at this graph, and try to see the logic I use to switch to create the circle. Because honestly, guys, I only really just remember these numbers and these angles, and everything else I just recreate when I have to. Okay, so that's it, guys. That's a unit circle, and I'm going to move on to the next section, which is trigonometry with triangles. Okay, thank you. Okay, guys, so the final part of this video is how we sine is related to a right angle triangle. So how trigonometry is related to a right angle triangle. So basically, if you have a right angle triangle, the and you have three sides, obviously, of a right triangle of any triangle. So if you want to find the sine of any of these, sine, cosine, or tangent of any of these triangles, you basically just have to remember these relations. So the sine of this angle is the opposite, which is b, over the hypotenuse, which is a. And the adjacent is adjacent of this angle over um, the hypotenuse, okay? And the tangent of this angle is the opposite over the adjacent, okay? So B over C. So there's a very easy trick that I actually learned in high school to remember this. It's actually so ka toa. Sokatoa. Okay? And Sokatoa is is just it saved me many times. It's sine is equal to opposite over hypotenuse. Cosine is equal to adjacent over hypotenuse, and tangent is equal to opposite over adjacent. So if you could remember SOHCAHTOA, you'll never forget these relations, okay? And yeah, so if you, there's many problems that we're going to see that we use these properties to solve the problem, okay? And yeah, so I'm actually going to do a really cool one in the next video, and you're going to see how powerful these formulas are. Okay, so that's it, guys. That's it for my trigonometry video. Thank you for listening, and look out for the problem video. The next one's going to be good. All right, have a good one, guys. And if you have any questions about any of this material, please don't hesitate to shoot it down in the comment section below. Okay, thank you. Goodbye.